Hello, everyone. Come on in. Hey, you tell. Come on in, everyone. Sorry about whatever happened. I don't know. I clicked on it and I'm sitting there waiting and nothing ever happened. So I got a reply from two of my students. And when I got that reply, they said they were there. So I just shut down Zoom and opened it back up. This time it evidently is doing the right thing. So I don't know what happened, but hopefully it won't happen again. It's not useful. All right, I think if I remember correctly, we had 12 students in the class. Right now, 9 of them have logged in. I see some names that I recognize. Nice to see you folks that had me before. Those of you who haven't had me before, cool stuff. And I'll warn you if you haven't had me before, I am horrible with names and I will probably do really bad, even though I'm trying to get better every semester. So don't feel bad if I don't remember your name, much less that anything's like if you tell me a specific gender pronoun I'm supposed to use. Oh God, I don't think I remember anything. I don't know, but I'll try my best and it won't be out of any disrespect or lack of caring for my students. I promise. Anybody have any questions before we get started? Because we're actually well into what normally would be class, but I don't, like I said, I don't want to wait anymore. Just since there's like 6 people not here yet. Ooh, excuse me, 3 people. That's better. Cool.
How's your summer been?
Not too bad. How about yours?
It was all right. Did some summer classes, but now I'm here starting the semester.
Getting ready to do it all over again. It'll be fun.
Yes, sir.
In fact, I just got back this weekend. I couldn't go to my convocation because I took my daughter to her to the college she's starting to attend up in Boone, and just had a really good time seeing that campus. And oh God, the temperature there never got over like 76. It was like the best thing ever. So I've decided I'm running away. I'm gonna move to the mountains and commute. Anybody have any questions about anything? I'm getting ready to talk a little bit about the syllabus and then that sort of stuff. And then I'm just going to go right into chapter 17.
Yeah, I just what's like briefly, how does this differ from physics 1?
Okay, so physics 2 is really, to be honest with you, the major difference is we normally do mostly electricity and magnetism. I've switched it around. We used to do electricity and magnetism, and then at the end of that, we would do thermodynamics. I'm now trying to build a transition for you guys. So I start in thermodynamics, which is much easier than electricity and magnetism. And then I go in electricity and magnetism. And that electricity and magnetism generally is the most mathematically rigorous stuff in the entire 2 or 3 semester sequence. So that's the thing that quote unquote scares people. But I got you. I can help you. We can do it. Easy peasy. Other than that, it's just basically the topics. That's sort of what happens with 241 versus 242, or any course, first part and second part. Normally, the first part covers X material and the second part covers Y material. And a lot of times, the second semester stuff is stuff that you really had no way of learning until you covered the first semester stuff. That's sort of what's here, because a big part of what you learned in 241 was vectors, actually adding vectors, multiplying vectors by scalars, multiplying vectors with a dot product or with a cross product or something like that. And then if you look at, for instance, electricity and magnetism, there's literally equations that have dot products and cross products of vectors within an integral. So that's and within derivatives as well and stuff like that. So it just there's really no way you could have done it in any other order.
All right, great. Thank you.
You're welcome. All right, so just to announce, since again we've only got about 9 people in the class out of the 12. Hopefully they'll get here. This is Physics 242. It's called University Physics 2. And like I said, we normally used to start actually, I'm getting a message across the top about closed captioning. I'm trying to make sense. It looks like it's something I've got to click on, but I do not evidently. Okay. So normally I'd start the class with chapter 21, which is on charge and stuff like that. And then we go up through 31 and then come back to chapter 17. But as I said, that is really sometimes a smack in the face, and occasionally I get one or two people drop literally the first day, and I don't want that. That doesn't help, and it's not really reminiscent of the difficulty of the course. I mean, if your first day is really hard, that doesn't mean every day is going to be really hard. In fact, that particular derivation I usually get to do on the first or second day of class is literally the hardest thing to do the whole semester, and everything else is downhill from there. So I'd say actually the second hardest, not the hardest, but anyways. So I've switched it. Now we start off in chapter 17, and that's what we're going to talk about today. As far as the syllabus goes, I want to give you some rough stuff, just some of the main highlights, but some of the stuff I don't want. This video is going to be posted on my YouTube channel, so I don't want it. I don't want like my private phone number or email to pop up on my YouTube channel. So I will be sending you messages with important information in that on the syllabus. So first thing I want to tell you guys is my email address. So y'all should take the time to go ahead and write this down. I know it's normally you can just see the recording, and you could come back and do the recording, but the chat's a little bit difficult, and I don't actually put the chat out there for you guys. I can, but I never do that. So anyways, I am typing it here, so it'd be good for you to write this down. Some of it you will see in the syllabus. Hopefully all of it eventually you'll see in the syllabus. Right now it's just not happening that fast. The syllabus has been created. We've been having some SIS problems, so I haven't quite posted it and everything for you. But this is my email address. Okay, I just sent that to the chat. What I want you to know about that is there's 3 things you got to do when you email me. Okay, thing the first is you must use your TCC email account. The second thing is you must start the subject line with PHY 242 night. Now, it doesn't matter what you can put after that. You can put anything you want after that. The main thing is it needs to start with that PHY 242 night, and that way I will see your email. Yeah, no problem, Jonathan. But the other thing is that, oops, yeah, we've got another person. So you do need to email me with that subject line, and that means if you even are replying to an email that I sent to you, you know how that works. You click on reply, and then it automatically puts in the subject line. That means you got to go up into the subject line, click to the left of that, and then type in that PHY 242 night again before that. So make sure you do that even on those, because if you don't, there's a good chance not only that I won't read it and reply, but that I probably won't even see the email. So that's 2 of the things. And the third thing is include, I want to say your full name, but what I mean is your first and last name. So the 3 rules are: you email me at with your TCC email account, you start the subject line with PHY 242 night, and thirdly, you include your first and last name in the email. So those are the 3 things you have to do to send me an email. Now, here's the other part. So my policy, which is actually a little bit more stringent than most of those places I've been. Most of the places I've been, we've always had a 2-day turnover. So you're supposed to get 2 business days to reply to an email. I've tried to make that 1 business day, and I have a very specific definition of 1 business day. So I'm going to give you that information right now. So what I consider 1 business day and the time within which you should expect me to reply to your email is, let's consider, for instance, a regular weekday like a Tuesday. If you email me as early as 12:01 a.m., literally like 1 minute after it became Tuesday, then 1 day, by my definition that I'm saying here, means that I should reply to you. Ah, crap, I just sent that include full name part to just one student. Means that I should reply to you by 11:59 p.m. Wednesday. So just before it becomes Thursday. So I can receive an email at 12:01 a.m. on Tuesday and not reply until 11:59 p.m. on Wednesday. And that would be considered one day. Now, if it spans a weekend, it's essentially what you might expect. So if you send me an email as early as 12:01 a.m. Friday, I need to reply to you by 11:59 on PM on Monday. So that's the other thing. So that's how quickly I should reply to you. Be advised, sometimes I reply, like if I get 6 or 7 students all emailing me with the same question, sometimes I'll just send out an announcement to everyone, and I'll do something like I'll say a couple students have asked, here's what this is. So that was really my attempt to reply to you. If you ask more than one question and I didn't address both, that might be that I'm a goober and didn't see both your questions, or it might be that and this is the more likely thing, is I read it and then I forgot it because I sent the other one. So anyways, that still means I screwed up. Okay, so if I only answer one of your questions by sending a group email, that's my screw up. Now, here's why I told you all that, in addition to just for your edification. There's also another reason, because specifically I'm giving you all this number. I'm typing it into the chat now. This is my personal cell phone number. And there's 2 reasons you should use that. And the 2 reasons are: 1, an urgent matter, and 2, I did not reply to you by in your email by the time period that I was supposed to. In other words, if I don't reply to you within 1 business day, as I just defined, then that's the time when you go ahead and send me a text and say, hey, Mr. Younger, I didn't receive a reply from you yet. Could you answer that question or something? Okay, so I just posted the number right there in the chat. What I want you to see, so obviously you've got the number now. Make sure you record that. I want to say number 1, it's for urgent things. And what urgent means in this case is, for instance, if it's a day that we have a test and I don't know, your tire's flat, or you got sick, or perhaps you've been in a fender bender or something like that. That's an urgent issue because I'm supposed to drop you guys if you miss a test. So if there's something that's going to make you late for a test or something, you should send me a text and say, hey, this is Mr. such and such, because you're supposed to say your first and last name in this too, from your 242 night class. You're supposed to say that too in your text messages. And I'm just letting you know that I know we have a test today, but there's been a whatever that happened. So that's an urgent cause. Now, I want to stress that our homeworks, for instance, since we're a Tuesday, Thursday class, our homeworks will be due generally at 11:59 p.m. on Mondays. So I cover about a chapter a week. Like this week, I'm planning on covering chapter 17. That means the homework from chapter 17 is supposed to be, it's supposed to be done by 11:59 Monday. So almost a week from today, 11:59 p.m., you're supposed to have that first homework assignment done. So if it's 8 o'clock at night on Monday and you realize, oh crap, I don't know where the homework is, or oh no, here's this homework problem I don't understand, or my webpage isn't working for my homework, any of that is not an urgent that is not an urgent reason. Okay, that's you wait until the last minute. So you can send it to me. I'm just saying I'm not going to answer. So make sure you guys start your homework or any kind of deadlines. Make sure you have already started to some extent immediately, so that kind of stuff don't happen. It's one thing to tell me, hey, Mr. Younger, I got in and got a lot of the work done, but then the night of, I missed 3 or 4 problems or something like that because I didn't get to do those. And in fact, that's going to count less off. So anyways, those are not urgent calls. Those are you just waiting for the last minute. So that's one of the reasons you should use my cell phone number. And as I said, the other reason you should text me on my cell phone number is because I did not reply in a timely fashion as defined by me. So those are the two things that you want to record as well about when you're supposed to use that technique. Now, I'm not, I'm not like just a person that don't care about my students or anything. So if if you happen to hear something cool about physics or astronomy or something like that, or even mathematics, and you're like, oh man, I bet you Mr. Younger like that, you can send me an email or you can send me a text. I don't care. That's cool. Okay. That doesn't bother me. If it becomes too onerous, I'll just say, hey, can we slow down on the emails? Because I do get a lot of text messages or emails in general. So I'll do that, and I'll be nice. And it's not anything about anybody personally. So, I don't care if you do or when I didn't reply to you in the one day that I defined earlier, from Tuesday, 12:01 a.m. to Wednesday, 11:59 p.m., that sort of thing. So what I want you to also know is when you do text me, your text should include one, your full name again. Again, that just means your first and last name. I don't need your middle name or anything like that. It's just a pain in the butt to write the word first and last. So your full name, 2 PHY 242 night. So you can just write that in there. You can just say, hey, I'm your night 242 class. And then actually, I think that's the whole thing. Yeah, that was it. So just make sure you include those two pieces of information in the text message. And that way I can know exactly who I'm talking to and about what. And you should be using it, like I said, for the urgent message or for the instant where I didn't reply to your email within one day, as I said. Any questions on that? Okay, so I've given you that information. That all that stuff will be on my syllabus. It's not right now. I think at one time I took it off for some reason. But anyways, I'm going to share my screen to go a little bit over our syllabus, and hopefully I have the syllabus where some of the private information is covered up. Yes, I do. I've got it scaled. So you see in this black version of our syllabus, I'll get rid of the editing details. But anyways, this is, for instance, my office hours, the lecture times. You'll actually notice this is for a different class. I just pulled this one up because I told you I was having these issues with yours. So obviously the class times and the lab times are not right. But the only reason I showed you this part at all, since it's not for your class specifically, was because it does have the office hours here. So that is really my office hours. They got kind of discombobulated in the process of going from PDF to, or excuse me, from one document to another type of document. So that's why I've got this weird like via Zoom thing aligned along the wrong column. But the main thing is, you see, these are my office hours. They will be posted in the syllabus, which will be in the helpful documents and links module within Canvas. I don't care too much about this email, so that's not a big deal. But still, I didn't really mean to put it out there. So there that is. This is the description of the course. This is sort of boilerplate generic stuff that every university or college in North Carolina more or less has to write this down for physics 242, for instance. Okay, so that's what I mean by it's boilerplate. And just like when you get into Canvas, that first module where it says, you've got student support, Zoom support, and all that stuff. That's stuff that's boilerplate, but that's boilerplate for all the courses at TCC. So I don't really go over that either in these intros to this course and to the syllabus. But anyways, here's something I did want to point out. So the school sells a package. You guys are 242, so chances are you had 241 like just this summer or the semester before that or very recently. I suspect there's sometimes a student that had 241 a year or two ago, so that's a little different scenario. But if you're one of these people that didn't just have it last semester or since we started using the 5th edition of Giancolli's textbook, then you're going to have to go and buy this stuff over again. So the student store, the bookstore, sells Physics for Scientists and Engineers with Modern Physics as a package. There's a couple different ways they could sell it, and I don't know exactly what ways they chose to order, but the bare minimum is they could order these little envelopes that have a user code in it or a user ID in it. And when you buy that, then you go into my Canvas. This is the way you do it for my course. You go into my course Canvas, and then you click on the first assignment, or you could click on My Lab and Mastering, but it's just as easy to just go ahead and click on the first assignment. And at that point, it'll make you create an account if you didn't already have one. If you already have one, it's still going to do the same thing, only you're going to have to put in your username and password from last semester or the semester before, wherever you were at, where you did in fact take the 241 course with the 5th edition of Giancoli. Because if you had the 4th edition of Giancoli or a different textbook, they're not going to honor that, of course. So anyways, that's what you're going to do if you have that package. Now, another way they sell it in the bookstore is that little envelope, but packed with or shrink wrapped with a binder ready version of the textbook. So basically, it's just all the pages from the textbook that you normally get, only they got 3 hole punches in them. So you can put them in a binder yourself, which is way cheaper than an actual bound book. So that's kind of nice. Especially if you're one of the people that prefers to actually read a physical text as opposed to reading electronic text. That's the thing about the passcode that you get. It allows you access to the My Lab and Mastering website, which is where your homework's going to be, but that's also where your text will be. It'll be an ebook there that you can access. So you could just get that envelope and you still have access to the book, or you could get the envelope with the binder ready version of the book, and then you'd have a quote unquote physical copy. I'm sure if you really wanted to, you could order the paperback edition if they have it, and you could order definitely the hardcover edition from the bookstore. But you don't necessarily need to do that. By all means, if you want to have the book, then by all means do it, but it could be very expensive. If, however, you're like me and you really like reading a physical book, the smartest, cheapest thing you can do is either go to the student store and get it. That's actually a little bit more expensive because the student store, they're a store, so they're supposed to make profit. So they mark up prices from what the seller sells them. So if you want to save a little bit of money, you can go to directly to the My Lab and Mastering site by clicking again on your homework assignment 1 and purchase it there. And what you do is you're going to just purchase the passcode basically. So that gives you access to the My Lab and Mastering and the ebook. So you actually have technically the new edition of the book. Now what you do, since you still want a physical copy, now you go on to eBay or Amazon or just do a Google search for Giancoli Physics for Scientists and Engineer with Modern Physics 4th edition. Or even do the 3rd edition. I'd say you could go back to the 3rd edition or the 4th edition, and you will not be harmed by using that to read the actual text as opposed to the electronic book. Okay, because that part doesn't change too much from one edition to the next. Most of what changes is they correct errors, they make up new problems, they get rid of old problems, they fix problems, and I literally mean the problems at the ends of the chapters. So that's a perfectly wonderful thing to do. If you want a physical copy, get a 3rd edition, get a 4th edition. And in fact, I worked on both I think I started working on the 2nd edition, but I know I worked on the 3rd and 4th edition. And specifically, I write their websites and author problems and stuff for those textbooks. And sometimes I'm just the guy that they pay to test them to see if they're correct. So I've done that with Giancoli and at least 2 editions, maybe 3. I've done it with a lot of books, but with this one I have. And I know for a fact the 3rd edition, 4th edition, and 5th edition are very, very, very similar, at least within the text of a given chapter. So, all right, so that's all the big deal about the book and the various ways you can get it. But again, I suspect that may have been helpful to 2 people in the class, but that's about it, just because everybody's in 2nd semester and probably had it recently. What I do want to say is you do need that textbook with the access to the modern physics, or what we call modified mastering physics. I don't know why I said modern physics. I think I was amalgamating the modified word and the mastering word. So anyways, you do need the textbook and you need the modified mastering physics website. And once you have that, everything's cool. But the main thing is, in addition to that, you do need a ruler, you do need a protractor, you do need a pen, a pencil, and an eraser. And graph paper, I'm not strictly requiring, but I promise you it'd be really, really helpful to have. It's really nice to be able to draw on that sometimes when you're doing some complicated drawings. Sometimes it's just nice to have the formality of vertical lines, like if you're making graphs. Or if you're just literally trying to draw a graph. For instance, one of the wonderful graphs that you can see is a graph that shows both the voltage and the current across a capacitor in an AC circuit. Being able to align them left, right, and up and down is really a wonderful thing, and that's what graph paper gives you. And in general, when we graph things, we used to have to do it, brute force with paper and pencil and try to use exactly the best scale to make it the graph as big as possible. So that's another reason to have it. Now, in addition to that graph paper, which I recommend but don't require, you do have to have a scientific calculator. Okay, it can't be the one on your phone. That's for starters. You cannot have your phone anywhere near you while you're taking the test and stuff like that. So we can't let you use that for your scientific calculator. That being said, if you're going to major in a branch of engineering, or physics, or chemistry, or astronomy, or calculator, one with like a big screen and stuff like that, I've always been a big fan of the HPs. Especially the HPs with big screen. But to be honest with you, after the HP 56, I haven't liked them as much as I like some of the TIs. So the Texas Instruments, another one, and Casio is another one as well. Those are all really good. If they have the big screen, that's really helpful. So you can actually see your calculation, see what you typed wrong. They'll have a statistics package that make it every bit as powerful as Excel, for instance. So again, if you're going to be an engineering major, a physics major, a chemistry major, or a math major is another one I forgot. But if you're also going to be a physicist, astrophysicist, astronomer as well, this might be a good time to go ahead and buy you a nice scientific calculator that's a graphing calculator. If you're not one of those, then I'd say just find the cheapest scientific calculator you can get. You probably already have one. Again, I know because you guys had 241 before, but like I said, I've seen some of the cheapest ones have been like, less than $10 at literally Food Lion or something. So, all right, just want to let you know about that. And evidently that was so important in the syllabus that I had to write it twice. So yeah, that's clearly an editing problem. So we'll kill that. This is again more boilerplate stuff about what's covered. Notice it still shows the old order, which was just electricity and magnetism. And in fact, this was back before they started adding the thermodynamics. So I'm going to go on and move through this. Here's more. Okay, this is kind of relevant. This is the description of how the course will go. So each week there will be 2 or more online assigned homework assignments posted by Monday to be completed by 11:55. It's actually 11:59, by the way, p.m. And this one says Sunday because that's a Monday, Wednesday class. The syllabus I'm using is for a Monday, Wednesday class. Your class is a Tuesday, Thursday. So it's actually by Monday at 11:59 p.m. Just to put that out there. There will be 2 types for each chapter, and sometimes you might have a total of 3. Okay. So the 2 types are chapter, then number, and then homework. Those are your homework problems. And then the other type is chapter, the number, and then conceptual. Those are conceptual problems. What I mean when I said there's sometimes 3, there are some chapters, for instance, chapter 19 is one of them, where it has a part 1 and a part 2 homework. So when that happens, that means you're going to have 3 homeworks to do. But what I usually do with that is, since you guys are meeting on Tuesdays and Thursdays, I would make the conceptual and the part 1 homework due at 11:59 on Monday, whereas I would make the part 2 due at 11:59 on Wednesday, something like that. Okay, so you'd have it done just the day before Thursday, which is your next class meeting. So that's all I need to say about the homeworks. There will be online tests. If you had me last semester, you know about those, but the way my online tests work is I basically realized that when people gave people take-home tests that sometimes I was the sucker that was honest, and I don't like that. It's a bummer. So what I decided to do is say, hey, I really don't know, and I can't enforce rules that I would want to enforce necessarily. So why not just give everybody the ability to do this? So my online tests basically allow you to do open book, open any book, open notes. You can even use notes that someone else took, as long as they weren't taken after I posted the actual test, by the way. But anyways, that's the rule. Is I'm really just trying to not let you get any information in any way from a person that's seen the test already. So that's, you'll see how the stuff is written up in these paragraphs. That's why I'm trying to do it that way, as I just wanted to lead off, try to head off any attempts to get information from someone who's already taken the test. Okay. So the online test, like I said, open notes, open book, open anybody's notes, open anybody's book, and even you're allowed to do Google searches. Okay. All of that's open and it's not cheating. The thing is, you have a limited amount of time, and I try to set it up where specifically I want you to do well on the online test. I want you to make a good grade. And the way I'm trying to do that is I'm trying to give you a little boost of confidence, because you know you have access to books and notes and the internet. And I'm okay if you missed, maybe there was one type of problem you didn't quite understand. Well, guess what? If that's the case and you're taking the online test, you're probably going to have enough time to do a search for it online and get some sense of how the problem's done, and then solve the problem and still finish your test in time. If you have to do 2 or more, I'm thinking it's going to be a really hard time for you to fit that in. And here's the kicker. If you're literally 1 second, if you turn the test in 1 second later than you're supposed to, there's going to be a 10-point deduction. If you turn it in 61 seconds later than you're supposed to, it'll be a 20-point deduction, so on and so forth. So there's a real good reason for me for you not to turn it in late. In other words, when I say late, I mean you're allowed a certain amount of time to take the test as well. So if the amount of time that I give you to take the test is 60 minutes, that means you have to turn it in right at 60 minutes. If you go 60 minutes and 1 second, I'm going to count that as a whole minute and therefore take off 10 points. Okay. So that's the only negative side of having it like that. But get this, even if you got that horrible online test score, you can take it again and it'll be different. Okay. So your online tests will not only be open notes, open books, open internet. They will be timed, but they're also going to be, hey, take 2 attempts or take 3 attempts and only your highest will count. So that's the way I do the online tests. And it usually is 3. Sometimes I do less, sometimes I'll do more, but basically I only take the highest one. So that's the online test. All my tests are comprehensive. So when you're having a test on chapters 5 and 6, for instance, that means you're having a test on 1, 2, 3, 4, 5, and 6. Okay. When you're having a test on chapters, let's say 17 and 18, since you guys are 242, that literally means you're having a test on chapters 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 36, and then 17 and 18. Okay. So that's what I mean by all the tests are comprehensive. That being said, I don't actively try to put anything from 241 in there, except maybe, State Newton's laws of motion or State Kepler's laws of motion or something like that. That's about all I'd ever really do. But the fact is, if you didn't learn how to add vectors, you're going to be up the creek in, chapter 21, for instance. So that, in that sense, I'm literally going back to chapter 3. Okay. There will also be face-to-face tests, and I guarantee you're going to have at least 3 of those. There will be at least 3 this time. Last time and previous classes I've only had 2, and they were worth 45%. This time I'm doing 3, and it's going to be worth 55%. So there will be at least 3 face-to-face tests. I've got the dates. They'll actually be on the syllabus in the little calendar of events, or basically the calendar. So if you go there, you'll see exactly what dates are supposed to be. They're actually days that we cut out of lab. We made them flex time for lab so that we can use a little bit of the lab time to take tests. So I like that. And that now gives me the freedom to give 3 face-to-face tests instead of 2, and they're going to all count equally. So I won't count the final as more than the previous 2. So you'll have 3 tests total, the sort of the first midterm, the second midterm, and then the final, and all of them are going to count the same. And what that same will be 55 divided by 3. If I manage to find the time, I could give you a 4th, in which case it'd be 55 divided by 4. Okay. And you're also guaranteed, I think I said, to have 3 online tests. And those 3 online tests, I drop your 1 lowest, but I don't have any intent of dropping your lowest on the face-to-face test. The main thing is no cell phone out during your face-to-face test. In fact, I'll amp it up a little bit. You're not allowed to have any kind of electronic device that can store notes, can store photographs, or can access the internet. None of that kind of stuff is allowed to be out while you're taking a face-to-face test. And if I find it out without you first getting prior approval from me, then you're automatically going to get a 0 for that test. And I might even consider disciplinary action. So don't cheat. I don't want you to do that. And don't accidentally do that other thing, because that's not even cheating. And you just, it's just what I have to consider cheating. The good news is I hardly ever get students do that. Okay. And the students generally don't do too bad cheating. I haven't had much of a problem with it. Let's put it that way. So make sure you do that. Try to get that practice test done in time, and then make sure you don't have your phone out during the test. I don't know why I just want practice test for a second there. But the main thing is, if you are one of the people from the military, for instance, they have to be on call. I know they're not supposed to not have their phone with them. Just let me know. Or let, in your case, because you'll have a lab with another instructor, let your lab instructor know, and they should work with you. They'll say, okay, that's okay. And they'll give you very specific rules, like you're supposed to take it outside the room and talk or something like that. So anyways, hopefully that doesn't scare too many people. So that was the way the tests and assignments work out. I don't think there's anything else big that I wanted to discuss on this. This is the tentative course schedule, if you will. The schedule was the word I was trying to get out earlier and just kept coming up with calendar. So here's the course schedule. You can see I'm booked to do chapter 17. Again, this is a Monday, Wednesday class, so this would be Tuesday, Thursday right here. Don't rely on these face-to-face or online test dates, because we have different days depending on what day of the week you meet. So I suspect, don't you guys have lab on Wednesday? Anybody can answer that in the chat, say. Anyone? There you go, Monday. Okay, so y'all have your labs on Monday. My other class must have it on Wednesday. So I've got to adjust that and just say that's when your test is going to be. But you're Tuesday. Yeah, that's better. I should have knew that already. But thanks, Sang. So yeah, your lab is going to be on Tuesday. So those flex times that they give us for lab, those will be days that you actually take tests in the lab setting. Previously, what I did was I required everybody to use a lockdown browser. So we'll have the computers that you can use in the lab, but there obviously aren't as many computers as there are students. So if you guys have laptops that you can use, that 1 can get on the TCC Wi-Fi, and 2 can run Canvas, and 3 can run Respondus lockdown browser, and can run Canvas tests and practice tests, then if you bring that, that'd be super helpful. Okay. So that's what we're going to do. I haven't decided yet whether I will stick to that, or I might actually make a paper test with bubble sheets. So in that which case you'd have to have bubble sheets. You turn those in, and then I'd get them from your lab instructor and grade them. I don't want to do that, but I had a little bit of an issue last semester that made me worry that maybe there might have been a little bit more cheating, even though I thought it would be quite difficult since I was in the room and everything. So let's just hope that I was wrong. Okay. All right. So don't pay attention, like I said, necessarily to the schedule. Just see how it's laid out. The main thing that's important here is you guys need to know that I'm going to try to cover 1 chapter a week. There's an instance, for instance, chapter 20, we normally don't even cover in this course, but I just can't justify personally offering a 242 class without covering the second law of thermodynamics. So what I do is I cover chapter 20 in an abbreviated way. So that might be a candidate for a class that I just use 1 day to cover. Okay. Chapter 17, if I don't actually get, for instance, enough of this done quickly tonight, then I might actually have to extend chapter 17 to Wednesday and, or excuse me, to Thursday and Tuesday of next week. That might happen, but, you know, it's not that big a deal. Okay. So that's the way this is going to go out. That is definitely the order and the chapters we're covering. So we're going to start in chapter 17. We're going to go at 17, 18, 19, 20. That will end all of thermodynamics and other what's called kinetic theory and stuff like that. And then from there, you go into chapter 21, which is where electricity and magnetism starts. We're going to ideally do 21 through 31. And then 31 is another one that I sort of give a little bit of short shrift to, which is just for it's basically going to take a single day to cover that. It's interesting. It's really cool stuff where you learn about the entire electromagnetic spectrum. You learn what wavelengths are what. You learn about the Poynting vector and these special things, but it's really not. It's a little bit more detailed than is necessary unless you specifically are going to go into electrical engineering or physics. So anyways, that's why I usually only spend about a day on that. Once we're done with chapter 31, our ideal scenario would be we jump to chapter 37, which is the old quantum theory, and then 38, which is quantum mechanics, and then 39, which is the quantum mechanics of an atom. That would be the ideal scenario. If we don't have time and I have to ditch 31 and 37 and 38 and 39, so be it. I really don't want to go any shorter than chapter 30 though. Okay. All right, so that's how all that works. You'll notice I'll have the actual days that are important to the calendar, which is, to you, which is like days that you have to withdraw by so that you can still get a tuition refund or a partial tuition refund, or a day that you have to withdraw by before you actually get an academic penalty. Now, I say that just because that's formally stuff I have to put in the syllabus. I rarely, if ever, have the opportunity to tell someone that they should drop the class or to even answer in the affirmative when they ask me, should I drop? Okay. Generally speaking, my students don't drop, and the ones that do usually do so without ever talking to me. They just do it. Okay. So I would recommend, if you're worried, you're stressed, you think you're not doing that well, it's stuff you're just not getting it, talk to me. Okay. You'll be surprised at what I can do to help you to try to make sure you succeed. I'm here to help you succeed. This is what's often called a weed out course for a lot of different things, medical school, for instance, and law school and engineering, all sorts of stuff like that. All the major sciences, would be traditionally considered a weed out course. I don't believe in a weed out course. I don't have a weed out course. I'm not going to ever offer a weed out course. So my job is to try to let you guys succeed no matter what. Okay. If you don't get the material, then you're just not going to succeed, but I'm going to try really hard to make sure that y'all can get the help you need to understand it. And some of it I push a little harder than is really necessary completely. So sometimes you might get scared because you don't know all the stuff that I'm teaching you. But sometimes that's because I'm teaching you a little bit more, because I know I've got some people that are really getting it. Okay. All right. So just keep that in mind. It's rare that I suggest someone to drop, even when they've, let's say, failed 2 or 3 tests in a row. Even then, on sometimes, I think I can think of one time. Yeah, one time maybe that I've suggested that a student should drop because they got that far behind. But that student was having a lot of problems and, hadn't done a lot of the homework. So that grade wasn't going to help them and stuff like that. So sometimes I do, but generally I do not, suggest students drop. Here's the, with some extra stuff in it that's not supposed to be there. Here's the grade scale. Okay. It's basically a 10-point scale, and I do deal with the 89.5 issue. Yeah, John, go for it.
Yeah, I had a question from last semester. I just want to make sure I'm understanding this. So the face-to-face, last time we did it last semester was Respondus lockdown with webcam. So are we going in person into your classroom, or how is
this one's going to be done in your lab?
Okay, in the lab.
Yeah, that's why you don't need the monitor this time. In fact, I had a little bit of issues with some of the monitor stuff last time. So our new chair made up, I stepped down from the chair, and she decided to give us flex time on our labs so that we could actually use some of the lab time for tests. Not much, just a couple of days, and we actually have 3-hour labs instead of 2-hour labs. So I think everything that's been done is consistent with the rules. So anyways, by doing that, you can take it, even as online students, you can take the test in a face-to-face setting without having to go to testing center, without using Respondus Monitor. So that's what that is. Now, you're still going to use the Respondus lockdown browser because, like I said, I have found people in the past, even though I'm in the room with them, using the computer to access the internet. Like I'll find an extra tab or two open, and I'm like, click on it, and it's like Chegg or something. So you still have to use lockdown browser no matter what. Okay.
Okay, does that also mean that we have less labs then, since you said we're using it during our lab time?
Yeah, but we're still meeting, like I said, the minimum number that sort of we've always used for the rules of they're not, I'm trying to think of it, the rules of basically a qualification process that schools go through. Accreditation, that's the word I couldn't get. So yeah, it's still consistent with that, but literally we had to drop like I think ultimately what happened is we ended up dropping one lab. Like we used to do in 241, we did linear graphing 1, linear graphing 2. Now we stop at linear graphing 1.
Okay, cool. Thank you, Professor Younger.
No problem, John. So as I was saying, it is a 10-point scale, and I do, do the typical thing. Whereas if you have an 89.5 or higher, then you're going to actually get an A. If you have an 89.4, you're not getting an A. Okay. If you have a 79.5 but not high enough to get an A, then you're going to get a B. Now here's where it goes a little bit different from the 10-point scale, and this is me trying to make this not a weed out course, and me trying to give you that extra little bit of a push to help you succeed. And that is, I will count a C at 68.5 instead of 69.5. And I'll count a D at 58.5 instead of 59.5. So that's what I mean by it's a little different than a 10-point scale. Okay. Here's the breakdown. And actually, this is not the breakdown. This is, oh, I grabbed the wrong syllabus completely. Okay. All this junk is wrong. Let me tell you what it actually is. So I'm sorry. I just realized I grabbed, I don't know if it's an old version or what, but anyways, this part right here is what's wrong. The online test will count 10%. Okay, so that part's right. The homeworks, I've now changed, instead of being worth 20%, they're now worth 10%. Okay, and that's the homeworks, not the conceptual. The conceptual is still worth 5%. But now that I have 3 face-to-face tests instead of 2, I have 55%, and each of them count equally. See, notice this one, we had the midterm only counted as 20%, and the final counted as 25%. I'm not doing that. I'm now giving you 3 instead of 2, and those 3 are each counted equally. They're a third of 55. If I can, I'll even try to fit in a 4th. Okay, but that would be some kind of way where we might have to use Respondus lockdown browser or Respondus Monitor, just because I don't meet with you physically in person. So we'd have to do something where you could take yet another online class without wasting a lab. I can't, we're at the threshold. We don't want to give up any more labs. Let's see, the lab grade's still 20%, and you still get up to 5% for taking the practice test as a bonus. So remember, that's your extra credit. For those of you who had me before, for those of you who haven't had me before, listen to this great opportunity that you have now to get on the ground floor. So email me right now at no, nothing like that. But no, let me tell you about the practice test. So one, practice tests are not within the traditional university model. They're not really even in the college model. Practice tests are things that we always looked at high school and middle school and elementary school teachers is doing. So we don't really like that. And I take a little bit of heat for that. Okay. So yeah, you can leave early if you need to. That being said, what I've done over time is I've realized some things. One, I realized students stop reading their book. That's a whole different problem. And actually, I don't even know if that's a new problem. That might have been the problem before, because I had problems reading the book as well when I was going through college, and I'm sure other people did as well. So that might not even be new. But another thing I discovered was that students now seem, other than maybe 10 to, I hope, 25% of the class, students will not do homework assignments unless they're getting points for them. And I don't know if you know this, but if you've taken 241 already, you probably do know it. If you don't do homeworks, you're not going to pass. So that was the problem. So I thrive to try to get back where students are doing not less problems, but in fact more problems. So my answer to that is for one, I give you a well-chosen, well-thought-out homework set, and I got the author to do that for us. And I say I got them, I'm just being funny. I didn't. That's just something they did. But using that homework set gives you a limited number of problems, but it doesn't give you that nice smooth transition from easy problems to more difficult problems. So that makes it hard. But still, if I didn't give you the more difficult problems, then they wouldn't bear any resemblance to the problems you get on the test, because you get a little bit harder problems on the test, not the hardest of the hard, but you do get harder problems on the test. So that's what happens when you try to limit the number of problems that you assign. I think your author has done a pretty good job choosing the problems that he did, so I use those. But again, they're usually on the order of 10 to 12, 15 problems or something like that. And to be honest with you, when I took physics, I would often do 50 to 80 problems per chapter. And they would normally assign about 10 to 15, but I would normally do, like I said, 50 to 80 because I wanted to make sure I understood stuff. Okay. So ideally, I'd like you to be more like that, so you're solving more problems, because that's really the key to success in a calculus-based physics class whose grades are based on your ability to pass tests. Okay, so how did I implement this? Well, I gave you that homework set, as I said, but I also am now giving you a practice test for every test, and I do a test every 2 chapters. So we're having a lot more testing, which is a good thing. My grades went from bimodal distribution to a much more bell curve type distribution when I switched to doing so many tests. So I felt pretty good about that. Even there is, cogent reasons for a bimodal distribution to not be unreasonable, or even a trimodal distribution to not be unreasonable. But what I've done is I have implemented a practice test that covers the material that the test is going to cover. And specifically, I've been so kind that I use exactly the same test bank as I used to make the test. So my guarantee is that you'll have at least 80%, but maybe as high as 90 or even 100%. Of the questions on the actual test will come from that bank that I was using for the practice test. What that means is if you had an infinite amount of time and you took the practice test an infinite number of times, and it wouldn't really take an infinite number, but I'm just being exacting here. So if you did take it an infinite number of times, then you will have seen every question in the bank. And because you've seen every question in the bank, you now are guaranteed to get at least 80% of the points from that test if you actually learned how to do those problems. So that's another reason for you to take the practice test. But from my perspective, it means, hey, they're going to take this practice test, and that allows them to solve 4 or 5 problems. Well, then they're going to take it again, because the more times they take it, the more problems they see and the more practice they get. So they're now going to have maybe 10 problems done, and then 15, and then 20. So next thing you know, you guys are doing practice tests, and it seems like you're doing just as many homeworks as I used to do. Okay. And I did that mostly on the chapters that I didn't understand. I'm not saying I'm super student or something like that. I was just saying, at least on the chapters that were really difficult, is I definitely would shoot for, in those cases, sometimes 80, 90, 100 problems. So anyways, I think by offering these practice tests and offering the homeworks the way I do, I'm getting students to do more problems than they otherwise would. And as an added incentive to do those practice tests, as if this is not enough, I do in fact take the highest score from each of the practice tests that you take or that are offered. So if you decide not to take the 3rd practice test, then you're going to get a 0 for that one. But anyways, I take the highest grade that you score on each of the practice tests, and I add those up and divide it by the number of those practice tests. So I get the average, which obviously could be as high as 100. And then I divide that score by 20, which obviously could be as high as 5. And that's the number of points I add to your total course grade. So that's literally like up to 5 points added to your course grade for doing these practice tests, which you should have done already. Does that make sense? Anybody have any questions on that? Okay, for some reason I always get this question, so I'm just going to ask it. Yes or no, the practice tests are required?
No.
Thank you. Okay, I don't know why I always ask that, but yeah, they're not required. Would you be crazy for not taking it? Yes. Okay, but they're not required. So just to let you know that. And again, I usually have about one student out of 24, maybe one student out of 48 that literally won't take any of the practice tests, and they'll still get, you know, an A. So that does happen, but literally it's like 1 out of 50. So that's like a 2% student. That being said, the people that otherwise don't take it usually score at best in the C category. Okay, so it's just a lot of reasons to take the practice test. Let's see if there's anything else up here. No. Just don't miss a test. Remember that. That's a problem. I'm supposed to drop you if you do miss a test, that sort of thing. So let's not do that. I'm going to stop sharing the screen now, and then I'm going to share the screen with actually with our Canvas page open. So I'm going to turn to the modules and all that stuff, give you a little intro to that. We're almost running out of time, so it's almost certainly true that we're not going to get to cover any of chapter 17 tonight. That being said, I've given you plenty of video links in week 1's module, so you can still start covering chapter 17. I do recommend it. I recommend you watch at least one of those videos for chapter 17. You'll see there's several of them down there, and almost all of the ones I give a link to are often like a whole class long. You don't never really have to watch the whole class, but you should at least watch the examples. If you want to watch the whole class, then it probably do you some good, but you can certainly fast forward over, you know, me talking about football at the beginning or something. So all right, let me go ahead and share my screen again. Yeah, that's the one I want to share. Okay, on this one. So we're now in our Canvas for our class. This is that generic one that I said was boilerplate for the entire school. Okay, so it's not that it's not important, it's just that it's important in every class, so you have a chance to see it in every class, and it's not special to physics, so I'm not talking about it. These things you're seeing how the sausage is made here. So so when you see a module like this and it doesn't have that green, that just means that's something the instructor sees, but you guys don't, so just ignore that. Like these are the old syllabuses or syllabi, however you call it, from previous semesters. What I really meant to show you a second ago, what I didn't. But anyways, in here you'll see, for starters, there's a Zoom invitation. I'm going to go ahead and remove that because, oh no, that's the right one. I just put that up there. Yep, that's it. So yeah, I forgot I'd already put that up there. So that's the Zoom invitation. And you'll notice it's a recurring meeting every Tuesday and Thursday, 5:20 to 6:40. If you ever lose your passcode or something like that, you're going to use that. Quick video on your syllabus. And then right under this will be your actual syllabus when I finally finish the pooping thing. But anyways, it'll be there. Here's that same incomplete list of my YouTube videos. It's still from 2022, so it's not up to date. Here's my YouTube channel, and here's my Google Drive. And remember how the Google Drive works. Basically, that's all the notes I've taken from all the things I put online on my YouTube channel. And you can usually find it by doing a search for the title, or if it's an actual lecture, you'll see that in the comment section of the video, it'll say like PHY 242080323 or 2023 or something like that. You do a search for that 0803 2023 in Google Docs, and boom, that'll be the actual picture or an actual electronic file of the actual notes that I was doing that day. So if the camera gets bad and you can't see it, or you're watching on a phone so it's too small, you can have access to it anyway. So that's where the Google Drive is. And that's where you can find all of the stuff, at least related to 242 videos. I've also made it so people that do subscribe to my YouTube channel, I tell them you can email me and I will give you access to my Google Drive if they're trying to get that. So even for 241, in other words, you can get it by just letting me know you want it. This right here are individual chapter practices. Those who had me before, y'all know what it's for, but if you haven't, this is like in that instant where you discover you're taking the practice tests. Let's say the first practice test, which is on chapters 17 and 18. And you're discovering that 18 is easy. You got that, no problem. But chapter 17 is giving you a problem. Well, you can now go to chapter 17 way down here, which actually I'm going to move to the top now. You can go there and just practice chapter 17 problems. And it's like a smaller number than the practice test is. And I never see your scores. I can see whether or not you did them. And I think I can probably see how many times you did them, but I never see your score at all. So that's what these are for. They don't count. They're, again, not required either. But the main thing is you have access to a single chapter's, not only the problems, but also the concept questions. So it has both of those in there. I'm sorry if y'all are hearing my cat. I don't know what's going on with her. I think Mama went outside with the dog and she's upset, but she didn't get fed yet. So she's a very vocal cat. Her name's Allie, as in Alley Cat. All right, here's the practice test. You can see practice test 1's already available. Notice the date's wrong, so I got to fix that before anybody can take it. Hopefully I'll remember to do that tomorrow. Here's where your online test will be. All of those are actually shown. I haven't decided whether I'm just going to make that the module called tests and all your online and your face-to-face tests will be there, or if I have two modules, one module called one module called online test and the other one called face-to-face test, in which case you put the online ones there and the face-to-face ones would be in the other thing. I haven't decided on that yet, but you know that's going to occur, so don't expect me necessarily to tell you what I decided. Just the day of the test, you're going to say, oh, there it is. Okay. Here's week 0. So these coordinate systems I find extremely helpful, especially for the 242 class as opposed to the 241 class. They're not really required material, but if you have some understanding of them, it'll make a lot of your life easier. So I put them on there. And Cartesian, cylindrical, spherical, and then spherical again. Oh yeah, part 2. Okay, so they're there. There's also subtracting vectors by drawing, adding vectors by drawing, the greatest vector addition problem. I still get a lot of students that have taken 241 other places and they come to take my 242 and they still have problems. They can't add vectors. So I'm one of those guys that wants you to have a chance, even if you screwed up in the first semester. So, you know, you can have your kumbaya moment now and learn how to do vector addition and vector subtraction and all that stuff. Even if you didn't last semester, here's an opportunity to learn. You can come see me. You can make a Zoom meeting with me, make an appointment with me, and I'll show you exactly how to do it. But that is something you're not getting out of my class without being able to do. So even if you pass to 241, but you didn't learn how to do the addition of vectors or say cross product of vectors, then you're probably almost certainly not going to be able to make anything other than an F in this class, maybe a D. Okay, so we just got to make sure you get up to speed on that, and I will move heaven and earth to help you get up to speed if you're behind like that. It's not a big deal. I'm not going to judge you. I just want to help you. Okay. Here's week 1. You'll see 18 showing, but it's not supposed to. I turned that off before, and evidently I must have turned it back on by accident. So here you'll see this is a lecture more or less on chapter 17 from 2022. Here's another one from 2022, a little earlier the same year. This is actually another one, but it's from 2021. So that one's going to have ones where I used a document cam and I did my handwriting stuff instead of the iPad. So that might not be as helpful for you, but they're all there. Here's kinetic theory. Here's another lecture. That's the most recent one. So that's probably the newest of all the chapter 17s is that guy. And I normally try to order them as the newest at the top. So I really should put that up here. All right. I'm going to have those videos or videos like that every week. and they're ones from my YouTube channel. Sometimes they're from other sources as well, but they're normally from my YouTube channel, and they're extra examples of solving problems that you can look at. They're usually whole lectures, like I said, which is not really what I wanted to do with my YouTube channel, but when it was thrust upon me during the plague that we had, most of my stuff got filled in with whole 3 hour and 1 hour and 15-minute videos. So that's why they're mostly that. I'm really wanting to slowly migrate back to 10 to 20-minute problems of videos, but I'll get there eventually. So here's your chapter 17 homework. This is what I was talking about. If you already have your account, or even if you don't, you still got to click here. And when you click here, instead of seeing this, what you'll see is a thing asking you to sign up for Mind Mastering. So that's there. The dates may not be correct on the Canvas side for when the homeworks are due, but the dates on the MyLab and Mastering side are correct. And if you ever find one later on in the semester and it seems like it's really jacked up on a date, you might want to ask me about it, because it could be jacked up on a date. But I literally think I took the time to correctly date all of them today. Actually, I did it last night. So hopefully that all works. But anyways, that's where you're going to go for that. Let's go back to modules again. So that's what week 1 will look like. And right after that will come week 2. You might see every now and then that I accidentally put a lab in there. It's an accident. I didn't do it on purpose. I'm not running your lab at all. So I don't have any power to say this is the lab we're doing this week. And I can't even put it in the syllabus, because sometimes certain instructors would choose to do a different lab on week 3 than I would have done, or I do in my, I said do, or I do in my face-to-face class. So anyways, that's basically it on that. We've basically covered everything, and I've only got about 8 minutes left of the class. So I'm going to stop sharing here, and I'm going to give you a little intro for 8 minutes. Okay. Richard Feynman, who did make an appearance in the Oppenheimer movie, by the way. So Oppenheimer, hopefully some of you have seen it. Hopefully all of you have seen it. It's really a good movie, and it is based on American Prometheus by Kay Bird and Martin Sherwin, I think the names are. Really, really great book. I love for me. In fact, that's the book that I taught, and I'm not recommending you do this. I taught myself to be able to read and walk at the same time, and I did it like in Milwaukee. So I was walking down the streets in Milwaukee, Wisconsin, reading Kay Bird's American Prometheus, and somehow I managed not to get run over. So it's really a great time, but it's really a great book. There's another book that it's partly based on called The Making of the Atomic Bomb. I think that's by Richard Rhodes, and I think it's like Rhoades. That was a book we assigned to our undergraduate students at Chapel Hill when they were taking nuclear physics, because the physics in there is almost non-existent in terms of equations, but the premises are discussed and the whole history of it's discussed. Some of the personalities are discussed. All the horrible facts are discussed as well, but it's really a great book. So those two are really amazing. There's several other books on Oppenheimer that are quite nice, but anyways, in the Oppenheimer film, there's exactly 2 scenes where you'll see someone. In one case, he's sitting on a hearth with some bongo drums. He was like, that's supposed to be Richard Feynman. Of course, Richard Feynman became a professional drummer. Richard Feynman, by the way, at the time, if I remember correctly, he's like 16 or 17. Recalled he was like 17. And anyways, he was in one speech he gave, he said, if there was one sentence that War 3 is happening, where everybody's nuking everybody. China's sending out all their nukes, Russia's sending out all their nukes, America's sending out all its nukes, and you can get a message off to, let's say, a band of 100 humans that have managed to build an underground world that they can survive through this, and they're nothing but kids. What sentence would you give them to help them the most? And Richard Feynman said it would be that matter is made up of these tiny, tiny, tiny things that we call atoms. And he just went into a slightly longer sentence. But basically, the idea was that these little atoms jiggle not only as a result of temperature, but because that is the definition of temperature, and they jiggle, and the faster or the hotter they get, the faster that jiggling speed goes. And at their coldest state, they form into little regular structures. And if you take them a little bit hotter, they absorb the heat and break those structures and then roll on top of each other. And if you go a little bit more heat and a higher temperature, they break those bonds that keep atoms or molecules next to each other, and then they become what's called a gas. So it's something like that. So I will tell you specifically that, yeah, the atomic idea existing is a really big deal. Yes, it was discovered, I think, in like 200 or 300 BCE by Democritus, and his argument was as follows. He said, let's imagine I have this little piece of iron, okay? I'm choosing iron because that's an element. I could have chosen titanium oxide, which is a compound, but then the smallest thing wouldn't be an atom, it'd be a molecule. So he said, let's imagine this piece of iron. He didn't know about molecules versus atoms versus compounds versus elements, but I'm just trying to give you that from a modern perspective. And he said, okay, there's two possible outcomes. I can take that piece of iron, cut it in half, take one of the halves, cut that in half, take one of those halves, cut that in half. And I can keep doing that, either one, forever, which made no sense to him, or two, I'm going to do that until I get to one piece that's so small I just can't cut it in half. Okay. And in fact, the word in Greek for divisible is tom. And if you put a prefix "a" on it, then that means not tom. So you basically came up with the word atom, which meant indivisible. So that was the initial idea or hypothesis that atoms existed. And the evidence he had for it, in addition to that logical experiment, was the idea that when you're 2 or 3 doors down from a baker and you smell them baking bread, that's those atoms, which we can read now as molecules too, breaking off, wafting through the air and entering your nose. And just to end this on such a great note, I will remind you that that's exactly the same mechanism when you smell flatulence. Awesome. So anyways, it really is. A molecule came out of that and it's now in your nose. So yay. But anyways, that is the idea of the atom. And it turns out that the idea of the atom is really awesome. And though that was discovered, like I said, on the order of 200 or 300 years before the Common Era, before Christ's birth, for instance, because of that, and before that, because of that, you would think we would have discovered it so long ago that we already knew definitively it was true. Well, it turns out it wasn't actually proven to be true until 1905, when Einstein did it definitively with one of 7 or 8 papers he wrote in 1905. Every one of them, or at least 5 of those, could have won him the Nobel Prize. One of them did. And one of them was a paper on Brownian motion. And that's basically where you drop little pollen grains on the surface of water, say a glass of water, and you'll see the little pollen grains doing this kind of stuff. Well, Einstein used what we thought we knew about the atom, and he used statistical mechanics, which is a form of statistics, basically, and calculated what he expected those pollen particles to do if atoms existed and behaved the way that we thought they did. And he made a prediction about what you'd see experimentally with Brownian motion, and he got it exactly right. And because he did it in a statistical way, we know that the odds of him being right and atoms not existing are sort of like winning all the lotteries for 10 human lifetimes, all the lotteries on planet Earth. Okay. So in other words, the probability is essentially 0 that he was right or he was wrong and got the right answer. So anyways, that was 1905 when we finally showed the existence of atoms. In fact, Einstein calculated that atoms were in fact about 10 to the negative 10 meters across. That turns out to be true as well. That idea of an atom and the idea that it's jiggling as a result of temperature, or is in fact the definition of temperature, that's very important. And from that, we'll be able to make conclusions about what happens when you heat something up and all that good stuff. So it's now 6:40, so I'm going to go ahead and let you guys go. You don't have to stay and say anything to me, but I'm not going to leave until the last person leaves in case y'all have any questions. So thanks for coming, everybody. I will do watch chapter 17, at least one of those videos, so we can play catch up next time. And like I said, I'm waiting for the last person to leave in case anybody has any questions. So Taylor or Julia, do y'all have any questions? It looks like they might not be here. Type them if you can. No.
Nah, I was here. My computer just kind of froze right before the end of class.
Yeah, mine did that just
I
before
was
class. Awesome.
I was writing in OneNote and all of a sudden everything just freaked out. So anyways, thank you, Professor. See
No
you next
problem.
class.
Sorry about rushing it, and I'll see you guys on Thursday.
You too.
Bye-bye.